Categorizing hearing loss based on the audiogram configuration: symmetrical, asymmetrical, unilateral eller bilateral, progressive or sudden. Degree: mild, moderate, severe. Type: conductive, sensorineural or mixed. So we can have normal is from 0 to 25 dBs hearing loss, and then mild, moderate, moderate, severe, and profound is from 91 dBs hearing loss, and so on. Yeah, and there's also some frequency areas. Normally, the hearing loss increases and getting worse with higher frequencies. Hearing loss type: we have the conductive. It is in the outer ear and the middle ear. It's conductive. The sensory neuron is from the inner ear and also the auditory nerve systems. So yeah, okay. Conductive is from the pinna, also to the you can say to the ossicles, including the ossicles, and then the sensorineural in the inner ear, cochlea, and auditory nerve system. Conductive hearing loss: reduced transmission of sound to cochlea. That was my problem. Reduced transmission of sound to cochlea. Can diagnose using otoscopy and tympanometry. What about the audiogram? Yes, we have some right ear unmasked and with a hearing level in decibel and frequency. We have some frequencies. There's an airborne gap here between the left ear and right ear. No, I have some right ear unmasked is lower than the left ear and also left bone, yes, yeah, and right bone, left bone, right bone. There's an airborne gap between, you can see here, yeah, on the graph. The right ear unmasked is lower than the airborne bone. Symmetrical sensorial hearing loss. You have bilateral sensorineural hearing loss. So there's no difference between the you can say with the unmasked right ear, left ear, right bone, and left bone. Okay. Yeah. And then we have asymmetric neural sensorineural hearing loss. There's a difference between the right ear and left ear, and yeah, and also some masked left ear. Yeah. When there's a crossed left ear and left bone, if they are the same level, for instance, then we have no air bone gap. Yeah. Yes. Yeah. Unilateral sensorineural hearing loss. Left ear. Yeah. Here is the left ear. Yeah. Yeah. Left ear. Yes. Okay. Newborns. How can we test if their ears are healthy? what objective test can we use? Otoacoustics emissions, UAE, auditory brain stem response, ABR. What is otoacoustic emissions? An OAE is a sound that is generated from within the inner ear. Okay, it's coming from the inner ear. For an UAE scanning, a probe is placed inside the baby's ear canal, tones or clicks are played, and the presence of a generated sound in response is recorded. So you have intermodulation distortion, where you have some waveform output and some spectra nearby each other, F1 and F2, 1800 and 2000 hertz, and then we have some, that's input, and then we have some intermodulation distortions at low and high frequencies components. Yeah, yeah, okay, and then we have some, quadratic combination tones. I can't remember all these things. Distortion products, UAE, a demo of auditory non-linearity. Yeah, in, out. Yes. Intermodulation, distortion produced by the non-linear behavior of the inner ear. Yeah. Yes. There's some extra frequencies, you can say. You have F1 and F2, then you have 2 times F1 minus F2, or 2 times F2 minus F1. Auditory brain response. Present repeated clicks measure potential on scalp EEG. Okay. EEG signal is equal to response to clicks and noise. Average sweeps to reduce noise. Two most common causes of hearing loss: aging and noise. Age-related hearing loss. Again, we have some audiogram. Normal hearing, 20 years old, have almost no hearing loss from 120 Hz to 8 kHz. And when you are getting older, especially for high frequencies, the hearing loss is going, it's increasing, or worse, you can say. Common complaint: I can hear you, but I don't understand. Stop mumbling. When you have some frequencies and a graph and hearing loss in decibels. Yes. Okay. Okay. And again, the hearing loss is more serious at higher frequencies. It can be, for instance, 20 dB hearing loss up from low frequencies, then increasing up to maybe 70 decibels at 8 kilohertz. Then we have some noise-induced hearing loss. Then we see here noise-induced hearing loss. Why do we see a notch at 4 kilohertz? I think at 4 kilohertz the hearing loss should be worst when it noise-induced hearing loss. I think it could be there is a minimum about 3,500 Hertz. I think it's because of this resonance frequency. When the noise and the signal frequencies are similar, the masking is have a maximum. Yeah, and you can say hearing loss is worst. Yeah. Threshold again. Hearing threshold. Transfer function of combination of outer and middle ear. Okay, there are some a frequency dependence of in dB of outer and in middle ear it goes up to about 10 dBs. We have this equivalent. We have some what's called sound pressure levels. We have LEQ and LEX. The principle is to use total or average energy. LEQ is equivalent steady sound level energy average over time. And LEX is sound level that over an 8 hours period provides the same energy. Yeah, okay. So some formulas for calculating LEQ and LEX. What is the limit of safe? It's about 85 dBA. And what is the level? What if level are over the limit? Require hearing protection, reduce exposure time. Example of a reduced exposure time: 8-hour shift, LEQ of 85 dBA, 4-hour shift. That means then it is increasing with 3 dBA, 88 dBA. A double, okay. If you increase the dB with 3 decibels, it means that you have to half the hour. A 2 hours shift means an LEQ of 91 dBA. Legal limits vary around the world. LEQ measured in classrooms. Consequences of conductive loss. By definition, implies increased audiometric threshold. By definition, implies increased audiometric threshold. Okay. Transfer function of outer or middle ear is linear. Loss is linear. Super threshold processing is normal. Deformation loss of pinnae potentially reduce spatial hearing. Okay. Normal hearing, yeah. Again, we have some normal hearing threshold and speeds in between music, audible area, and threshold of discomfort. And for hearing loss, this impaired threshold curve is increased, yeah. Or else, but the threshold of discomfort is the same, yeah. But the hearing threshold is the hearing threshold is increased. Yeah, you need more sound level for an impaired ear than for normal ears. So the curve is lying higher, you can say. Consequences on sensorial sensorineural hearing loss: audibility, perception of loudness, masking and frequency selectivity, temporal resolution, spatial hearing, speech intelligibility. Consequences of sensorineural hearing loss is audibility, perception of loudness, masking and frequency selectivity, temporal resolution, spatial hearing, speech intelligibility. Thank you.